Hi everyone. So I'm gonna go ahead and get started with the workshop. So I'm gonna start by sharing my screen. And just gonna ask to make sure, can everyone see it?
Yes, sir.
Yeah,
I can see it.
all good? Perfect. So pretty much this is a circuit building workshop for just the beginner level stuff because the breadboard and MYDAQ is gonna be needed for electronics 1, electronics 2, and I think it's circuits analysis or circuit design. So like MYDAQ is something you're gonna need to get familiar with, and I know for me, like my lab person just brushed over it and was like, okay, go ahead and start. So hopefully this is useful for all of you. So welcome to everyone who joined. And so pretty much to start is the breadboard and how it compares to the normal drawn circuit. So for the positive and negative terminal on each side acts as one node. So this whole length is connected, and then the whole minus to minus is connected as well. And so essentially, in case you don't know what a node is, this line to this line is one node. Then here is a second, and it's just the same idea. What the heck? And here's a third, fourth. So each separate line is just a node. And now this is the basic idea is the breadboard, each column down the numbered side is one node. So all these are connected. And then the next row, each row over, so 30, this would be 30, 29, 28, 27, 26, 25. And the point of them being numbered is to help organize your circuit, because it can get very messy at times. And so we're going to, I'm going to show you what an example of this circuit would look like on the breadboard. And so these two, this is connected to the positive terminal. So this is where the current will be coming out. And then this connects to that, just like that, it's shown in the line. And since it acts in series, you connect this to this terminal here, because this is the first terminal, the plus right here, and the charge goes to the first resistor, which is on the second node, which here is the number 20. And then on the same node is the second resistor connected in series. So they connect along with each other and move along here. Then the second resistor on the after the second node, we'll get here, which is just a wire. So I'll hop over. We'll be on, this is the third node now, and it connects to this wire alone. And so there is no real part on this node, it's just continuing the flow. And then the third node connects back to the battery where it would be grounded. So it connects here, and so this will connect into the battery again, grounding the electronic. And so just that's like the basic idea of putting the breadboard together, like configuring a circuit on the breadboard. And here's the MYDAQ. Hopefully it's clear for you guys. And so with this has just a bunch of terminals to plug into your wires. The one I used is A01, which is over here, and then A0 ground. And so the terminal themselves, you'll be pretty much told which terminal you need to plug in your volts for. And that will be what it will do for you. So it'll be told for you. So then you already know that you're plugging in which wires to the, like where you're plugging in your wires on the MYDAQ. And then you just have to worry about putting it together on the breadboard. And so here, see if I can move this. That's better. So here is where you would plug in the readers. And you can't really see it too well, but the black is the ground. It would be reading the circuit flow across. And so that'll be used for measuring resistance, voltage, or amps. And the red terminals, the right one is for measuring amps, and the left one is for measuring voltage and resistance. And so here, I'm going to, let's see this. I'm going to take you to see what the measurements and how you'd be using the MYDAQ. So when you plug in the MYDAQ to your computer, you'll be connecting it with a USB cable, and then the option will pop up where you can pull this out. And so for the MYDAQ, you'll be needing digital reader and DC level. Just give it a second to load up. Maybe not digital reader. Let me double check. Digital multimeter, my bad. And so here, when you're measuring in the lab, you'll see this is the DC voltage output. This is an AC voltage. It's for DC current, AC current, and resistance. This will basically just help you. You have to make sure you have it on the right setting, otherwise it could get confusing. So for this one, I'm just going to be measuring with the DC output. So setting it up, I have it at A01. And I'm going to set it to 5 volts. And we're just going to start it. So normally you see a graph pick up like that. And then here we're going to set up to read amps. We're going to set it to, we'll set it to auto. Hopefully it'll work well. So when you hold the reader, I'll show you in a second, but you need the red terminal out in front and the black one later on. And so by measuring, you'll see it'll be 2.3 milliamps. But if you put the black one forward and the red one backwards, you'll see it'll give you the same result. It'll just be negative. So it's important to be careful about that, because in the lab, the sign does matter, and it could change your grade either a lot or a little, depending on which teacher you have. So I'm going to show you exactly what I mean by reading it. So I'm going to stop the screen share for a second and put on the camera. We're going to try to focus it. I hope you could see it well. And so this is the voltage out, or the current out, goes into here. and follows this path all the way through back to ground. And when you're measuring, you want the red out in front and the black behind. And so that's how you'll get your read for the ampage. So let me hop back off the camera and go back to screen share. So that's about it for this part. Okay, so we're gonna stop this and stop this. We're back onto the sides. And so another thing you're gonna be using a lot is the op amp. And so the op amp looks like this. If you have a circuit kit, you'll see it. And the diagram of itself looks like that when you're working on it in class. When it's written on paper, it will look like the triangle. You have the plus, minus, and all that. And so the terminals, it goes from this circle, it'll be 1, 2, 3, 4, 5, 6, 7, 8. And so here is a general idea of how you'd plug it in. This would be your voltage outward or whatever you're measuring the output of. Typically it's voltage. For 8, there's no connection. And 5 and 1 is for more advanced cases, so it's not something you need to worry about. And so 2 and 3 would be your negative inputs, negative and positive inputs, and would be like would be part of the, sorry, I lost the word, just, it would be important for the output. And the plus V and minus V basically determines the limits to where the op amp can boost the voltage or whatever you're boosting. So in most cases, it's negative 15 and positive 15. And so basically that voltage in from both ends will pretty much cap the voltage change to anywhere between negative 15 and positive 15. So continuing. This is just examples of the op amp formulas, so then you can always see before you actually before you actually submit or just trust the reading, because this is a good way to check that your work is right. So if you measure, it'd be RF over RN, and so it would just, so just for an inverting op amp, inverting, it's obvious that it's going to be switched to negative. And so it'd be the final resistance over here, since there. And it'll be 1 plus our final over our in. And so what I can do is I can well, let me ask you first, what's the circuit and measured on the MYDAQ?
Let me see if I can find one for you.
What was that? You kind of broke up.
Let me try to get one for you.
Okay.
1 sec.
Can you see it now? I'm not sure why it's being like that. Okay, good. Sorry about that. And so basically, you have your tools on the side here, and for pretty much all circuit building programs, it'll be pretty much formatted like this. And you just build your circuit how you would if you were to draw it. So you just go down, or even go in the search bar, just battery, click. And then you have your battery set up. And if you wish to edit it, let's see. On the selection tool, click, and then you can just set up the resistance how you feel. Do 1000. Then hit enter, it'll change. You can see it there. Same thing here. You can switch this to maybe switch it to 10,000. Here, do, let's see, DC, and you can just make it volts set, and then you'll have your thing set up. And you just click to run it.